Hi there. So this is the Step 1 2004 Question 1 solution. I've always liked this question. I think it was probably one of the first questions I actually managed to complete fully on Step, and so I often give it to students when they're first sort of like thinking about maybe looking at some of the questions in this paper. Anyway, let's get on with it. 3 plus 2 root 5 cubed. Now this part 1 really is what I would describe as a settler question in this exam, as in like this particular one, part 1, is definitely not too bad. Okay, you've still got to fiddle around with a bit of arithmetic, and remember this is a non-calculator paper, but really there's not much to it. Now you could just multiply this, by itself squared, and then multiply it by itself once more. But to be honest, that's not really the flashy way of doing it. It's probably not the quickest way of doing it. The quickest way is to, that's not a slow way either, but just the quickest way is probably to use binomial expansions. So we'll get 3 cubed plus 3 times 3 squared times by 2 root 5 plus 3 times 3 times by 2 root 5 squared plus 2 root 5 cubed. Okay, now we're just going to simplify that to 27 plus, now that's going to give me 27 times by 254 root 5. Apologies for my poor handwriting here. Plus, okay, that's going to give me 9 times 4, which is 36 times 5, because the root 5 will be squared as well. Don't forget to square everything. And then plus 8 times by 5 root 5, because root 5 cubed, remember, is root 5 squared times root 5, so it's 5 root 5. So it's worth remembering that. Okay, let's just tidy up a little bit. We've got 180 there, plus 27. That's going to be 207 plus, and then we've got 40 plus 54, and I guess that's 94 root 5. Okay, so sorry if that looks like a 6. That's 207 plus 94 root 5. And I think that's just a little warm up to the main question because it doesn't come in particularly handy if memory serves. Okay, anyway, the next bit, it's just to warm you up for the next bit, because when I look at something like this, cube root of 99 minus 70 root 2, and the question tells me I've got to find positive integers c and d such that this is the case. When I look at something like that, I think there's really not many things I could do or think of doing other than to cube both sides. And I guess I'm on the right track because they've just got me to multiply out a bracket cubed. So I guess they were just trying to warm me up for that. So I just continue on my merry way, if you like, and cube out the right hand side, but I'm going to keep writing down the left hand side of the equation to remind me what's going on, because in the back of my head I'm thinking this is probably going to be an equating coefficients problem, but we'll see. Okay, I've got c cubed plus 3 times c squared times by minus negative d root 2 plus 3c times by negative d root 2 squared plus negative d root 2 cubed. And just as I was doing on the line above, I'm going to simplify that. C cubed. Oh, the signs are going to alternate, I've just noticed. So that's going to be minus 3c squared d root 2. Next bit's going to be a plus. We're going to get a d squared, so a 3d squared, but the root 2 is going to be squared, give me 2. So that's 6cd squared. And then finally, that's going to be minus 2 root 2 d cubed, for the similar reason that root 5 cubed is 5 root 5. Okay, and I'm going to write down the left-hand side again. I insist on it, because then I can clearly see why this is an equating coefficients problem. Let's zoom in a little bit. Well, the thing about rational and irrational numbers is they're kind of like, you can't mix them up. If a number's being multiplied, if you've got an integer which is being multiplied by root 2, it looks like an irrational number to me because of the root 2's irrationality. Whereas if you've got integers which haven't been multiplied by root 2, clearly they're rational. And so I'm going to match that kind of thing up. So I'm going to immediately link the 99 with, if I can write it down over here, the c cubed plus 6cd squared. I'm going to be linking that to what I'm underlining in red here. And then if I underline this in this garish green, I'm going to link this up with minus 3cd squared c squared d minus 2 root 2 d cubed. That clearly must represent my irrational part. Oh, I've missed out the root 2 there. Apologies for that. That looks really messy once again. But can you see I'm matching up the ones with root 2's in there to the 70 root 2. And then what I can do is take out, I can now come up with two separate equations, if you like, of 99 equals, let's do a little bit of factorising just to tidy it up a bit, c squared plus 6d squared. And I've also got 70, and let's just ignore the negative there and the two negatives here, because then we can say it's all positive. Really, this is the same as 3. Now let's not factorize it as well, because it might you might not be happy with doing two steps in one go there. But 3c squared d plus 2d cubed. Brilliant. And let's quickly factorize that into d times 3c squared plus 2d squared. Now, at this point in the question, this is probably where you get stuck and have to think a little bit, because remember, we've got to find two integers, c and d, such that this is true. So now we need to find two integers, c and d, such that these equations are true. Well, this is a funny thing. When you know it's definitely an integer value that you're looking for, you can kind of use, especially because they've just asked us to find the value of c and d, just find it, just locate it. We can kind of use like an inspection method where, I think, well, what about 99? That's kind of got a few factors. It's like got 3, 3, and 11. So I've got it as a nice prime factor decomposition here. So I'm expecting one of these two factors to be equal to 9 and the other one equal to 11. Or maybe one's equal to 3 and the other one's equal to 33. Or maybe one's equal to 1 and the other one's equal to 99. But, that should be possible. Now, you can kind of guess. Similarly, over here, by the way, we're going to need 70. Think about the prime factor decomposition of 70, you've got, what is it, like 2 times 5 times 7, yeah? And so once again, maybe this is 35 and this is 2, or maybe this is like 10 and this is 7. There's only so many possibilities. There really is. So at this point, I guessed. That's genuinely what I did. I thought, well, maybe C is 2. Maybe C is 3. It looks more like 3 to me. Maybe this C equals 3. In which case, that would equal 9. And in which case I want this to be 33, yeah? Sorry, is that right? No, I want this to be 24 because together with the c squared, it's now adding to 33, and 33 times 3 is 99. Now, if 6d squared is 24, that gives you d equals 2, yeah? They did, I can't remember if in the question they said they were positive integers or just integers. Positive integers, yeah, so I don't even have to worry about the case where d is minus 2 here. So I know c is 3 and d is 2. Okay, that's kind of nice, but does it work in the other one? Immediately I'm checking it. 2 times 3 times 9 plus 2 times 4. What's that give me? 8 plus 27 is 35 times 2 is 70. I've found them, yeah? Lucky guess, if you like, yeah? Lucky guess. And that's what I genuinely did in this question. I don't think it's bad to do it. You can see what I'm doing. If you want to make it look a bit more professional, those words by inspection, by inspection, and which means I just inspected the problem and worked out C is 3, D is 2. Marvelous, I've done part 2, and that's what I like about this question. It's actually really doable. Now, part 3, what's this doing here? X to the 6 minus 198x cubed plus 1, I think it was. Let's just quickly scroll up and check. My memory's getting worse and worse nowadays. Okay, yeah, plus 1 equals 0. My first thoughts with this is, what's this got to do with any of the other parts of the question? Because normally they link. But secondly, I look at this and I think, quadratic in disguise. You definitely want to be looking at something like that, thinking quadratic in disguise, yeah? And okay, maybe it's not part of the rest of the question. Maybe it's just completely on its own, yeah? But I'm going to look at that as quadratic in disguise and let u equal x cubed. Because then I can see I've really got u squared minus 198u plus 1 equals 0. And I'm going to try and solve this because they wanted me to find the two real solutions of that equation. I guess they're implying that there's another four solutions which are imaginary, which is interesting once you've done imaginary numbers. But this was from a paper which didn't require any imaginary numbers, and yeah, I mean, you don't need to know anything about imaginary numbers really for this. We just need the two real solutions. So we want solutions, I guess, from this quadratic, and then we can use the substitution u equals x cubed and cube root our solutions, and then we've got x. So I guess that's the answer. Okay, so if I'm solving a quadratic, especially if the middle term is even, I'm going to use completing the square. Half of 198 is 99 squared, yeah? Now you might think, oh no, but now I'm going to have to square 99 in my head. Yeah, because you don't get a calculator. Come on, this is a step paper. Of course they expect you to be able to just square 99 in your head. Do it the quick way, 100 minus 1 times 100 minus 1. Then you've obviously got 10,000, and you can do this almost in your head, minus 100, add 1. And so that's going to be, what is that, 9,801. But then we've got a plus 1 after that equals 0. And so we rearrange this, and we've got u minus 99 that's obviously going to be negative 9,800 in a square root. And then when we add the 99 over, make sure you got your plus or minus before the square root, you get this. And you think, oh, sorry, one more extra 8 there. And you think, whoa, okay, that's looks a bit ugly. But when I look at this, I also think, well, surely I want, some kind of like simplification of this if I'm about to cube root it. So yeah, let's try and simplify it. We've got u equals 99 plus or minus. Okay, there's actually two square numbers which spring to mind straight away in there. 49 goes into 98, and clearly it's 9800, and 100 is a square number. And if you times two square numbers together, you get another square number. In other words, 49, 4,900 is a square number. Obviously it is. Its square root is 70, yeah? And so what I can do is write this as root 4,900 times by 2, and so that is u is 99 plus or minus 70 root 2. Yeah, 99 plus or minus 70 root 2. Now, what were we just working with? 99 minus 70 root 2. At this point, it should click. There was a reason we did that to help with this. Typical step question. They're trying to teach you how to do something, really. It always feels like you're being taught. Anyway, so our roots of our original, I think they call it sextic or something like that, or I'm not sure, hectic, but a polynomial order 6, our roots are x equals the cube root of 99 plus or minus 70 root 2. Now, we certainly know the 99 minus 70 root 2 bit is what we just worked out. So we can say thus x equals 3, and I think our answers were 3 plus 2 root 2, was it, for our original question? Because we already know that the cube root of this, when that's minus, is 3 minus 2 root 2. Okay, and that was here, 3 minus 2 root 2. Now, it did say find two solutions, and we've got most of the marks now. So what's the other one? Well, you haven't got to think too deeply to realize it must be related to this one. Yeah, it's obviously the answer to the cube root of 99 plus 70 root 2. Yeah. Now, if you ignored a lot of the negatives which we were working with earlier, you should be able to quickly justify in your head that if you had to work out this as a plus, it doesn't take too much imagination to think, well, maybe this would be nice to write as a plus as well. And I'll just very quickly do this because I don't think you should spend too much time on this bit. If you let that equal c plus d root 2, you're just going to get exactly what you had before, but there's going to be pluses everywhere when you do that, when you've actually put this over here and you've done the expansion on c plus d root 2 cubed, you're going to get exactly the same as what you got before, yeah, except all of that's going to be positive. So this time you're going to have positive 70 equals that, and you're going to have 99 equals that. You're going to get exactly the same values, but because we were assuming it was c plus d root 2, you're actually going to get 3 plus 2 root 2. So I'm going to write underneath, by inspection, and that's always my get out clause. I'm not sure if they'd like it in every single situation. I'm not Mr. Perfection on these papers by any means. Like, feel free to criticize if you feel it's necessary. But okay, so we already know that's going to be equal to 3 plus 2 root 2. I'm just gonna, yeah, maybe I should write here, you know, clearly same working, but with positive signs. And so we can say by inspection, x is 3 plus root 2 as well. And that's our other real solution. Okay, hope you enjoyed that video. It's just, yeah, it's a nice little step question. I really enjoy that one, I must admit. It's a good one. All the best and keep up the hard work. Bye-bye.